project. Like I said, it was Monsanto kind of leading the way, interested in soil health. Pioneer's also interested in this, and they're putting money towards it. There's at least 6 other sites that are doing similar research. They're allowing each state kind of give it their flavor. So what I went with was actually dairy forage system type setup. One thing that we're interested in having big plots, something that relates more to the farm. So each plot here, remember the other plots that I showed you that were 15 by 50 feet? These are half an acre in size.
Yeah.
So they're 50 feet by 500 feet. So we're using the farm's large farm equipment to manage it. But a lot of these companies are realizing that, yeah, all these genetics give you this advancement, but you know, there's still a wall, and so that's why they're using soil health. You know, it's the next step. You know, the management side of it. So we started the project. Laura will talk about it. Laura actually came to work on her master in September of last year, and I actually was able to get all their funding. So right now the funding to sustain the project comes from the Agronomic Science Foundation, which is part of the American Society of Agronomy. They're fantastic to work with. And they basically paying for the base funding, what I call the base funding. We actually have to rent this land. We are actually on private land here. It costs us about $13,000 a year just for a rental, because we have a lot of land in here. Luckily, the station worked with us, so if they make any money on the whatever they harvest here, they give us some back. So they're very nice to work with. Mike at the station, Mike Burke at the station, they're great to work with. So I was able to find other pot of money to be able to get a grandson, which is Laura, to work in other issues that are related to this. And what I was interested in is looking at also runoff losses, but then I'm using a different approach here that I propose to do. But also then looking at the soil health issues and seeing that if that's better health of soil turns into better water quality, better health of the water, I guess if you will. So with that, I'm going to let Laura talk about her, and I'll just serve you as Vanna White and hold the papers.
Yes, that's Francisco. Actually, with these large plots too, we're kind of mimicking a dairy forage system. So using big plots and kind of doing exactly like what a farmer would do to make it more realistic. I don't know if you guys can see, but this was corn silage. That bottom there was corn silage, and then these two are alfalfas. And then over the hill, we actually have another alfalfa and another corn silage. So 6 altogether. So quite a big plot size. And here's the replication. So corn, 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 alfalfa, 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 and they stay this way for 3 years. 3 years, yep. And then we flip flop.
We're flip-flopping this year. So just to get an idea, we're roughly standing here.
Yeah, here we are.
So this is alfalfa, this is corn, alfalfa, and then it's flip-flop.
Yeah.
So randomization.
Yep. So we're looking at sustainable uses, so using cover crops and no-till. So the treatments we have on each plot, we have no-till with cover crops, no-till with cover crops that we harvest, no-till with no cover crop, and then conventional till, cover crop, conventional till, harvest the cover crop, conventional till, no cover crop. And again, we talked about the big plot size. It's very productive soil, I should say. So it's still loam and focusing on a lot of different aspects, again, soil health, productivity, runoff, and phosphorus loss. So one of my biggest interests is working with water and looking downstream and what happens to the water after it runs off the field into the lakes and streams.
So Laura is very and when she was there working as an undergrad, she was able to work on some screening, like running looking at fossil surveys and looking at the impact, you know, of the health of their population. So that's kind of, now she's looking at the upstream, you know, what the management is doing to the downstream, which she's already worked with. So it's kind of neat. That's one of the things that when I talked to her on the phone, I was excited to have her on board. Plus, she actually scuba dive inside a beer.
A local brewery. We had to scuba dive inside their tank that was broken. So it's all their beer waste.
So it's like, cool, you're awesome.
I remember
you're hired.
The first interview on the phone with him, and as soon as I said that,
Yeah.
as soon as I said that, I was like, I got it.
think I've done that, but not with scuba gear. Yeah, anyway.
So getting back to the plastic, a big thing with leaving no-till or cover crops is the amount of residue that's left on the soil, which we know is important. So we see different percentages with each treatment. So with conventional till, we see about 15% or 5% depending on cover crops. No-till, we get even more with 20% and up to 70%. And alfalfa, of course, we have about 100% residue cover.
So the other thing you're seeing here is these frames. So for looking at the runoff, we use a different approach. We use what's called a rainfall simulator. Do you have a picture of it?
Yep.
And so these frames, we pound them in the ground.
They're 3 feet by 3 feet.
To basically, that's our collection area. That becomes our sampling area. Which is different than the other ones where we're collecting runoff from the entire flood area. Obviously.
So like at Melanie's, they were collecting natural runoff, so to speak. And for mine, we used a rainfall simulator. So a lot of equipment. It took about 4 tractor loads of equipment. And it's kind of this big tent with 10 feet above the ground, a big spray nozzle to simulate rainfall. And we used 3 inches per hour, which simulates about a 50-year storm. So not too uncommon anymore to get.
Starting to be more like a 30-year return period.
Yeah.
Yep. And we sprayed it for an hour on each plot. And here, so you can see the water, and then there's like a hose, a suction hose that collected the runoff that we received.
And so that actually has a suction. You say that they need it all collects in this vessel in here. So we could measure the volume, total volumes, and then after each run was done, we can actually mix that up and then collect samples and look at phosphorus and other things, sediment loss.
Yep. Then I looked at the different sediment, all the sediment losses, and then various types of phosphorus. So I think every type of phosphorus loss there. And another kind of new thing that we did was we used deionized water in the rainfall simulator, which hadn't been done as much in the past, but we thought it would be imperative to do because a lot of the well water around here, most of it's high in nitrates and other minerals and calcium, so we wanted to again simulate real rainfall.
Some of those can interfere with the phosphorus losses, especially calcium.
Did you measure the starting moisture content?
We did.
Moisture content? Yep.
We took samples right beforehand, and it rained about 3 days beforehand, so it was pretty saturated soil. I think it ranged between 15 to 25% moisture, so it was perfect conditions.
And they were all pretty even across treatment.
Yep.
So we were very lucky this past spring. The conditions were just right.
Yep.
This approach.
Did it right at the
That's a very
beginning
good
of June.
point.
That was a good question. Yeah.
Because the moisture content, when you start the simulation, it will affect the runoff.
So here's some data from the different trials, I guess, to run. So a big thing was when we first got runoff was a big deal. So how long it took to actually get runoff. We see here's the alfalfa. It took the longest to receive runoff, and we received the least, which was kind of expected. And then the no-till with cover crop, again, it took longer to receive runoff, and we received less. This one is no-till, no cover crop, and then the 2 highest were both conventional tills. So it was pretty neat to see. The data turned out pretty great.
So it was more of the tillage versus the cover crop or no cover crop that was
Exactly.
Yep.
Yep, exactly.
Yep.
So again, we have the total runoff in inches, how much water was infiltrated, and then again in inches per hour infiltration. Alfalfa had the most infiltration, and again, the 2 conventional tills had the least. And Francisco always makes a good point when talking to farmers, and a good way to think about this is if it's not going into the soil, it's just running off and you're losing that water for your crops.
Exactly.
Can use it. So like here you're only losing 3/4 of an inch, where over here you're losing 2/3.
And if you remember from my video with Serge Koenig for Sauk County Land Conservation, he mentions in there that in Wisconsin, we really don't have a runoff issue. It's an infiltration issue.
Right.
We're really
Yep.
we're losing 70% or so of the water that strikes the ground in farming situations and agriculture situations.
What is the profile? I usually
Right.
add to this when I'm talking to farmers. A decent soybean corn crop in Wisconsin needs about 24, 25 inches of rainfall, or water, not rainfall, of water, during the growing season. A nice silt soil, deep like the ones we have here, which are the ones that hold the most available water, can only hold between 10 and 12 inches of water. So then over half of the crop needs have to come during the season, so it behooves to have the best infiltration capacity to make the most out of that water. So, anyway.
It's kind of hard to tell on the fields now, the different treatments, but at one point it was really, you could really tell the difference in how dark and moisture some of the no-till and cover crops were, so
So it was a challenge this spring being so wet to do the harvest and then do the tillage that needs to happen, apply manure, so we're applying manure to everything, so we're trying like a dairy system. So the cover crops were just planted 4 days ago. That's what I was looking, it was on the 10th.
Yeah.
Today's the 14th, that's what I was looking on the time. So
Yeah.
that's why we don't see it in the cardinal, but you can see where the no-till drill, or the drill.
Did you say what the cover crops are, Francis?
We're actually using cereal rye.
Cereal rye. Okay.
So the treatment that Laura was talking about earlier, she's not doing runoff on we didn't do a ripple simulation of that one. We have one where we're harvesting the rye as a ryeage in the spring. So that's part of the reason we call it rye, and it's a true and dry, pretty robust cover crop,
Sure.
in my opinion. So that's why we're using that.
That's what you use too, right, Connor? Yeah. Connor's
confusing, right? So I use it a lot when I was in the south. We're awesome there. Throw it this high. Yeah, great. Roll it down, man. Weed control, awesome. And then strip tilling it. Sorry, I get excited.
no, that's great. Always learning more about. This was some preliminary data that I collected. So I took those samples from the water, subsamples, and then ran it for sediment loss. And we can see no-till, no cover crop, conventional no cover crop. So in this two with the no cover crops, we saw the most sediment loss. When the no-till with cover crops, we saw the least. Alfalfa even less. Phosphorus, kind of a little more all over the place, but total phosphorus again, the no cover crops seem to have the most phosphorus loss.
So, Bob quiz. What would be why this would not probably be following the sediment loss when you're looking at phosphorus losses from a field? What are kind of like the two main kinds of phosphorus? So maybe I'm not pitching it right. But it would be phosphorus bound to sediment, so it would be what we call a particulate phosphorus, right? So that's easy to see. The other one would be the dissolved phosphorus, which is to me the hardest one to control because it's what's dissolved in the water. You don't see it, and you know we know what to do to control sediment losses, right? We kind of got that down fairly well, but you know. To control actual runoff losses, sometimes it's very difficult, almost impossible to get a good rainfall event that exceeds your filtration capacity. There's nothing you can do. There's still phosphorus being lost there too, matching other things too. But anyway, so that's why these doesn't quite follow this, because this is the total, and where she's actually looking at the dissolve and the particulate, so she's looking at that how that partitions.
And I was shocked too when working with phosphorus that this is in parts per million, and so 1 to 2 parts per million. So I thought at first that was kind of low. But with phosphorus in waters to cause eutrophication, you need very, very little amounts. 0.03 can cause parts per million can cause eutrophication. So phosphorus is a big, big issue with dealing with watersheds.
Downstream effect.
I used a different piece of equipment just to compare to the rainfall simulator. So like I mentioned, that rainfall simulator needed a lot of different moving parts, where this guy, the Cornell Sprinkle Infiltrometer, it's a very small instrument, and you can easily bring it just in the back of your car and go wherever. So I wanted to compare again all the data over again. So this time the ring though is only about this big, and again you can see the different residue coverage. And then we just let it kind of drip onto the soil, and then we collect the runoff this way. And then I collected the runoff and tested all the phosphorus sediment loss again. Cumulative runoff, very similar to before. Alfalfa with the least, no-till, cover crop with the not as much, and then the two conventionals with the most runoff.
So the interest I have on this being an extension person is, instead of having to take that other stuff that would be almost impossible, we almost got two semi-loads to dig in all the fields.
Yeah.
And we use this as a tool to, it's not going to be the same as the other one. The other one's more like natural rainfall. This is obviously not. But in this at least give you some idea on how their places around the state might behave, kind of get more information and different geographic type of different areas.
So I found it was quite similar. A lot of the sediment loss, we saw the same trends.
And you're looking also to at phosphorus.
Yep,
Yep.
all, redoing it all. Yep. The last thing that's part of my project is conducting a survey to hand out to farmers all throughout Wisconsin. So as Francisco was mentioning before, it's important to make those connections with farmers, knowing that, not knowing, but they need to apply it to their field. So we need to know their needs and what they want to see happen. So this was just two examples of questions. So it's actually kind of, so the farmer fills out the front sheet, and then if he does use cover crops, or he or she doesn't use cover crops, they answer differently. So like what are the three most important factors that prevent the use of cover crops on your farm? Trying to pinpoint those reasons that they're deterred away from using cover crops, or what is the most important research topic pertaining to cover crops? So what do they want to see we do at the university? Like what do they want to know?
What might be a barrier of their operation that prevents them from doing cover crops? That maybe we can help out with. And the idea is that we're going to be running some of these this year, and then maybe in a few years we'll submit the same survey again and kind of look over time if there's a change too. So, and we try to keep it. Laura, when she was developing this idea, was to keep it pretty brief, right? So if you answer no cover crop usage, there's only one more page. It's only 2 pages, and if it's yes, there's 3 pages total.
So it's just 5 to 10 minute type of quick survey. So that's my project, and I'm just starting my second year. In 2 weeks, I'm going to redo all the rainfall simulations again. That's the plan to compare.
If weather cooperates.
Yeah. So when we did it the first time, the corn was sprouted about this high, and now we want to see after harvest what the differences are there.
Yeah, we were hoping that we would have some cover crops, but I'm pretty doubtful. Didn't get to it until late. So, but that's farming. That's the way the season was.
Still get some sprouting cereal around.
Yeah, just a little, kind of little peach moss like this.
Yeah. Exactly. All right.
Cool.
Any questions? You guys have or thoughts?
So with something like this, since you're working with Monsanto, how much do they ask for your data or how to apply it? Is it with the mindset that we want to change how our production's doing?
So they have been interested on the yield so far part of things, because I know the other stuff kind of takes time with the soil health and the other things that we're measuring. So obviously they're interested in the productivity, helping farmers kind of move to the next level. But they know that what's doing it's the management, is the health of the soil. So they've been pretty good to work with so far. Fairly hands off. They're not. Here recently I had a request from one of the guys. They have a similar setup like this one with the dairy forage. So there's other states around the Midwest where they're doing similar work. They might be doing corn grain or other things. The one in Michigan that they're running, it's doing silage type scenario, and they have very similar treatments. And they want to combine the data, so we have data from 2 different states. They're being very open, very nice about it. Like, hey, we'd love to combine this data for our internal use and stuff, and we would love to have you if you want that data for that side of Michigan. They are running it themselves. Monsanto is running it themselves. For a publication and other things too. You'll be open to